Hi everyone, welcome to chapter 3. So in this chapter we're going to talk about a few primary things. First, we're going to talk about variables and what they are, how we measure them, and how they're kind of organized. Then we're going to talk about the three different types of claims that we can make as scientists and as psychologists, and the ways that we kind of structure these different types of claims. And then lastly, we'll talk about 4 different ways of validating those claims using different validities and how we can kind of assess each type of claim using a different form of validity. So let me kind of switch over here and kind of get everything set up, and we'll go ahead and get started and take a look here at chapter 3. All right, so like I said, we're going to first talk about variables themselves, then we'll get into the 3 claims, and then we'll talk about how we can interrogate or assess those claims using these 4 main types of validity. All right, so variables first, variables themselves. So a couple things about variables is first, it's really important to distinguish between a measured variable and a manipulated variable. And so we kind of do 2 different things here when we're talking about variables, and they are used in different types of studies and designs. So a measured variable is one that we just kind of observe naturally occurring, and we kind of take a look at what's happening with that variable and just say, this is what's going on, but we have no influence on it. We don't actually manipulate it or have anything to do with what's going on with the variable. So they're observed and they're recorded, but that's really it. Manipulated variables, on the other hand, are controlled. They're ones that we actually have some influence on, and we have some manipulation to affect the outcome of these variables. So we control them in some way. So some variables can only be measured. They are not able to be manipulated, though some variables we can do both, right? We can either measure or manipulate and do some levels of both. So we'll talk about kind of each of these as we go through this as well. So when we describe a variable, there's kind of a few different steps that we take. So first off, we need to define what that overarching idea that we're trying to measure is. And we call this what's called the construct, or the conceptual definition, or the overarching idea of what we're trying to measure. So the construct or the conceptual variable is generally the name of what is being studied. So an example here might be our satisfaction with life, or maybe just generally persistence. So these are just overarching ideas. They're nothing specific. They're just kind of the general idea. And we can get a little bit more specific with the conceptual definition from there, where we have a little bit more detail in how we are thinking through and organizing what we're actually trying to measure. So if we look at our first example of satisfaction with life, maybe our conceptual definition is specifically a person's cognitive evaluation of his or her life. And so it's a little bit more specific, but not so specific that we know exactly what we're doing to measure it, but it is more narrowed down than just the overarching construct. Same thing with the second example. So our persistence, or the ability to push through when confronted with obstacles. So we're getting a little bit more detailed, but not exactly specifying what we're specifically measuring quite yet. Finally, we have our operational definition, or our operationalization. This is actually what we're measuring, or how we're going to choose to measure the variable or the construct itself. And so for our first example of satisfaction with life, maybe we design some type of questionnaire here, and we have some way of assessing using some series of questions ranging from 1 to 5 on some type of Likert scale. And we have identified that these are the specific ways that we're going to assess this construct in this way. And that's our operational definition. It's specific, it's detailed. Same thing for our second example. Maybe we have identified a specific way here that we want to measure using very specific details of how we're going to measure this ability to push forward. Maybe we look at how long they'll engage in some type of challenging or boring or slow-paced activity, and we use that measurement as a way to assess their level of persistence. So you can see how we get more detailed kind of as we go. We start with a general idea and then move forward and work through to a more specific, defined way of measuring that specific thing. We can also look here at some more examples of this and kind of see how we can transition from that overarching idea of an operational definition into more specifics of what we're doing here. And so if we look at a couple examples of this, we can kind of identify what's going on. So for example, maybe the first one here, our variable of vaping experience, that's what we're interested in measuring as a construct. And maybe we define this through a way of, asking teens how many times did they engage in vaping over the last 30 days? Or have they engaged in vaping at some point in the last 30 days? And if we ask them that way, well, then we're defining this with only two levels. Either yes, they engaged in vaping over the last 30 days, or no, they didn't. And notice here that this is a measured variable. We're not manipulating anything in any way. We are just measuring, we're observing what's going on. On the other hand, we could take a different example. Let's say down here, like the number of social media likes a teenager receives. So we could maybe decide how we want to measure this. We could either measure or manipulate this. But let's say we wanted to manipulate it. We wanted to have a little bit more control, a little bit more context on what we're actually looking at here. So maybe what we do is we bring in a group of teens, or we have some controlled group of participants, and we assign them in, say, a chat room here. And some participants, some teens, are assigned to a group where they receive 2 likes on their posts, and a different group receives 5 likes on their post. And these 2 different groups we then compare. So we have 2 levels, either those that received 2 likes or those that received 5 likes, and we can compare those 2 groups and say, was this different from one another? And notice that this now is a manipulated way of looking at a variable, because we have some influence, some control over what's going on. We're not just observing this in the natural world. We are controlling this. We are manipulating this in some way. We can look at another example here, kind of from start to finish, and say, let's say we want to understand the idea of school achievement. So that's our construct, that's our operationalization, is our school achievement is what we want to measure. And so we can do this in a couple different ways, right? So how do we measure school achievement? How do we decide on how to measure it? Well, we could choose to look at grades, right? We could say, how many grades did you get over this last semester or these last couple semesters? And use that as a way to operationalize the construct of school achievement. Maybe instead we could look at the actual records. So kind of comparing these two here, one would be looking at the actual records of what your grades were. The other would be, say, a self-report of your feelings of what your grades were. And there's pros and cons to each. I think normally, with looking at self-reports here, we're going to get easier, faster data. It's going to be more, less challenging to collect data like this, where participants just respond with their own information. Whereas looking at actual records is going to require some level of control or some extra level of access to be able to do that. So we might choose one over the other for different reasons that are not specifically about why we want to measure it one way or the other, but outside factors that might mean it's easier to get in one way versus the other. A third way we could look at school achievement is maybe just through teachers' observations. Maybe instead of looking at the grades themselves, we could look at school achievement based on how teachers observe students' ability to perform in the classroom. So the point I want to make here is that we can take a single construct and we can operationalize that construct in different ways. So there's multiple different ways we can take one construct and turn it into different types of measured variables and how we do that. So that's an important distinction, I think, to make, because sometimes we might want to select, like I said, a variable measurement or an operationalization for a specific reason, because maybe it's easier to collect self-report data than to actually find the true records of that. And again, there's trade-offs. Maybe one's more accurate than the other, but one's easier to get or something like that. So all of these are kind of important points to keep in mind and to understand when we're talking about variables and how we kind of define or operationalize these variables. Okay, next section here we're going to talk about is 3 claims. So we're going to talk about the 3 main types of claims that we make as psychologists, as scientists, and kind of go through these here. So the 3 main types of claims that we have are frequency claims, association claims, and causal claims. And it's important to note too that not all of these are always going to be based in research. Sometimes we can make these types of claims completely outside of research itself. So it's important to kind of understand what these are, especially when you, as sort of a consumer of research, are reading or hearing news or articles about what's been done, understanding kind of the value and the takeaway of each of these types of claims is really important. When we look at some of these examples, again, some examples of, say, frequency claims, which we'll talk more about in detail, are just generally observations about things in the environment. So maybe we just observe that 39% of teens admit to texting while driving. That's an observation. We are just measuring the frequency, how often something is occurring. Association claims, on the other hand, are now looking at pairs of observations, or looking at the association or the pairing of multiple different things in the environment. Usually these come from things like correlations, which we'll see, but maybe an example here is, say, playing an instrument is linked to better cognition. That's an association between playing the instrument and cognition, and we've drawn some kind of association between those two things. And then lastly, we have causal claims, which again have some type of manipulation, some influence, where we're saying one thing is a direct cause to another. So in this case, again, maybe music helps to fight off pandemic-related stress or some study finds that music helps to fight off stress, or maybe family meals help curb eating disorders. So these are specific causal claims that we might try to make. So let's kind of dive into these a little bit more each and talk about where each one comes from and how we can discuss those in more detail. So again, a frequency claim is really just looking at some observation where we're just observing kind of what is happening in the world and how often it's happening. And these are valuable in the sense that I think they're a great place to start. We kind of need to use these to get a baseline of what's happening and what's going on. But remember, we're only measuring variables in this case, and we're only measuring one variable. So I think that's an important distinction here. We're measuring one variable and just saying how often is that one thing occurring. And it's important, again, to keep in mind the value in this assessment. And when we get into the ways of assessing this through validity, we'll see that we need to be careful about how much we take away from these if it has or hasn't been measured in a good way. So that's an important piece to keep in mind for this as well. Association claims, like I said before, are really where we observe now multiple variables, typically at least two variables, and we're drawing some association or some relationship between these two things. And usually these are said to come from correlations, right? So we can draw this association through some type of statistical correlation. And this is important to kind of discuss as well, which we'll see in a second, that the direction and strength of these might impact kind of how we assess them and what we take away from them. So when we talk about association claims, we're really talking about correlations, and we're talking about how variables relate to one another in different ways. And so let's take a look now at some different ways that we might see these correlations kind of come out in when we're seeing these relationships. So we might first see a positive association. So if we see a positive association between our two variables, in this case, we see, say, cognitive ability with how much we practice some task, we can see in this case, we have a positive correlation. So it's a little bit hard to see in here, but there's a trend line, and you can see this trend line generally is sloping upward. We see a slight positive trend, and this is a pretty minimal one, but sometimes you might instead see some examples of trends where the data might look a little bit more positive in nature with a steeper curve. But the key here for a positive association is as long as it is going upward, as long as that trend is in an upward direction, that is a positive association. And so we talk about positive associations being related to variables changing in the same direction. So as one variable goes up, increases, the other variable also increases. We see associations with one variable that is high, with associations with the other variable as high as well. And same thing vice versa, where we see low values in one variable associated with low values in the other. And that's where we get this positive sloping trend. On the other hand, we can look at negative associations. This is just the opposite, where we again see this downward slope of our line kind of going in this downward direction. Let me see if I can do that a little bit better. So again, this one's a little bit hard to see, but let's assume that the line goes down. We see this negative slope, And this tells us, again, some negative association. And what that really means is that variables are changing in opposite directions. So as one variable goes up, the other variable goes down. And it doesn't matter which way we draw these, right? We could have one variable go down and the other variable go up. As long as they're changing in opposite directions, we would assume this is a negative association. And if we look here, we can really see this as higher levels in one variable are associated with lower levels in another variable. So we get high values in one, low values in the other. Low values in one, high values in the other. And that's where we get this negative slope within our data. So these are, again, negative associations. And then finally, we could also have a zero association. So this is just that there really is no association between the two variables in our data, and we get essentially a flat horizontal line as a fit curve to our data. There's no slope within our data, and there's really no association between the two variables. And so this is important, I think, to keep in mind too, because this does happen, and we need to be careful about how we interpret these. And really, we shouldn't put any weight into these because we're saying there's no relationship between these two variables. All right, so we have positive, negative, and zero associations that we can talk about when we're talking about those association claims. Again, when we make predictions based on these, we need to be careful about how much emphasis we put into that and how useful those claims actually can be. So we need to look at a couple things in that correlation and in that fit between our two variables. So we can have associations that are stronger than others. We can have a strong positive or a weak positive association. So it's not just the direction, but also the strength of that relationship that we need to keep in mind as well. So when we talk about these, really what we talk about is associations that range from a value of -1 to a value of +1. And anywhere on this line, we could have some association or some correlation value. In the middle, we have 0, which is no association, or that zero association. And so we have some range of positive associations, and we have some range of negative associations. And both tell us something about the relationship between the variables, but we need to keep in mind that a strong positive correlation is going to be potentially more valuable than a weak positive correlation or a weak negative correlation. But a strong negative correlation, again, could be valuable as well. So we need to keep in mind both the direction, positive or negative, but also the strength. That's an important piece of this as well. And the third kind of claim that we can make are causal claims. So causal claims are where we support these not through a correlation, but through an actual experimental study, right? So a study that has been manipulated, we have some manipulated variables that we control, and we can draw direct conclusions or direct outcomes from what we've controlled, what we've actually changed. And so when we talk about causal claims, again, we're really talking here about experiments. I like this slide. I like this kind of like chart here because I think it's very valuable to kind of see the difference between how we can talk about these two types of claims, or at least association and causal claims, especially when looking at research and publications and news articles and how all of this gets presented in the world. I think it's really important to see this distinction here. And a lot of people do kind of mess this up. A lot of people that aren't sort of in the science field, once it gets to sort of that news reporting cycle, these might be changed, right? So you can see association claims are things like is linked to, is tied to, is correlated with. And these only bring with them the level of, conclusions that associations can bring. They can't draw conclusions or causal directions or causal relationships between the variables. On the other hand, causal claim verbs or ways of describing these relationships are things like causes, affects, changes, worsens, increases. And I think that what we see a lot of the time is that researchers might make association claims in their research, and then the news may take these and misreport them using causal claim verbs. And I think it's really kind of important to understand that just because you see a causal claim verb in, say, a news article or news reporting, it doesn't always mean that it was actually a causal study that was done. And so I think this is kind of an important thing to be aware of. And we see that here too, again, just so not all claims we read about are based on research, and not all people writing about these are researchers and understand this distinction. So I think it's important for you to learn this distinction so that you're informed when reading and understanding other research. All right, and the last section we're going to cover here in this chapter is looking at the four big types of validities, and specifically how we can use these four types of validities to interrogate or assess our three different types of claims. And so let's go ahead and kind of look at these. We'll look at both frequency, association, and causal claims using these four big validities. But first, we need to talk about what the four big validities are and kind of go into and explain just what these four are. And so the first one we have is what's called construct validity. And so construct validity is really just the idea. So we talked about how variables start as constructs, right? The overarching idea. So this is looking at how well does our variable, does our operationalization actually assess, actually measure our construct, right? So we could do a really good job of measuring our construct and defining it very well, coming up with questions that address that construct in a very good way. Or we might not do a good job of that. We might have low construct validity when we're making these assessments. So this is a really important one. It's really saying, here's the idea, here's the thing you want to measure. Did you do a good job of measuring it? So that's construct validity. Statistical validity is our next one here. And this one really states, based on the numbers, the stats, the data that we're looking at, how much does the numerical side of things support the claim we're making? So if we're making a claim that X is associated with Y, and we talk about how important this is and how big of an association this is, but then our statistics only show a very, very weak positive correlation, well, we probably don't have very high statistical validity because we don't have the data or the numbers to really back up the claim we're making. So statistical validity is just how much do the numbers, the values, support the claim that you're making. Then we have internal validity. And internal validity here is basically looking at when we're looking to make causal claims specifically, we're looking to see basically how well does the claim that we're making, the causal claim of variable A, say affecting variable B, how much is that actually coming from variable A on variable B? Or could there be some other outside factor, some unmeasured thing that's going on that might actually be causing what we're observing? And so internal validity is really important, especially in causal claims, to basically make the argument that yes, this variable that I am saying causes this other thing. It is coming from the variable that I'm talking about. And so internal validity, highly important for causal claims. And then lastly, we have external validity. And external validity is really the idea that whatever we measure in our study, whatever we measure in our data, how well does that translate to the outside world, to the larger population? So whenever we talk about measuring participants and samples, we look at assessing a small group of people as our sample, and that group is meant to represent the larger population because we can't get every single person in our study. And that population might, again, not necessarily be the entire world, but it could be a certain subset of people. So the population might be UCF students, and our sample might be, people in this psychology course. And so our external validity is if we use our sample of people in this course to take this study, how well do the results generalize to all UCF students? And so if it generalizes well, then we have high external validity. And if it doesn't do a great job, it's really just applicable to psychology students or people in this class, well, then our external validity might be lower. All right, and so I like this slide too, because this is where we really kind of get to break things down a little bit more and look to see how can we actually assess each of the claims using the four main validities. And so what I want to do here is kind of just like go through each of the claims and kind of, assess each of these. So frequency claims, remember, just looking at how often something is happening, how often something's taking place. And so for construct validity, pretty straightforward. It's really just the idea of, are we doing a good job measuring what that thing is? So if we have some frequency of something occurring in the world, do we do a good job of measuring that thing? It's pretty straightforward, and you'll see that's pretty straightforward across all of our different types of claims. For statistical validity for frequency claims, we can look at, specifically things like the values themselves, and we can look at things like point estimates, which we'll get into a little bit later in this course, or margin of errors. How good is the estimate that we're making? So when we look at some frequency claim, are we assessing everyone and saying this is the frequency? In this case, we have almost 3/4 of the world laughed yesterday. This is the frequency claim in our example. And so obviously we can't measure every single person in the world. So we have to measure some smaller group of people. And is that statistical validity? Are our statistics showing that this is the case with the group that we measured? And then again, for internal validity, for a frequency claim, we're actually not making any causal relationships. So we don't really assess internal validity when we're looking at frequency claims. And then external validity, again, remember we're measuring a small group of people to represent the larger population. So how well does this represent? So if we looked at a group of people, maybe here in Florida, and we said, well, this group of people, 3/4 of them laughed yesterday based on some self-report survey. Well, does that do a good job of representing people in the entire world? And if it does, well, great, we have good external validity. Association claims, let's look at those. Again, these are looked at through primarily a correlation, looking at a correlation here. And for construct validity, same thing, but now we need to look at both variables. So do we do a good job operationalizing both of the variables that we're looking at in this association or in this correlation? And if we do, fantastic. But now we have to think about both of these variables. Statistical validity, we talked a little bit about this, but again, the idea that do our statistics, does our correlation, does the value of our relationship show the claim that we are making? If we say there is a strong relationship between X and Y, does the correlation coefficient, does the value of that relationship represent that? Is it a strong relationship? Is it a weak relationship? Things like that. Again, internal validity, we're not making causal claims, so we really don't assess internal validity here either for association claims. And then external validity, same idea. So if our claim is playing an instrument is linked to better cognition, well, who did we measure? Who was in our sample? Was it people that already played instruments? Well, maybe that doesn't translate as well to people who don't play instruments. And so we need to be careful about that external validity. Maybe it does. Maybe everyone gets a benefit from this. But this is how we would assess this. We would look at, does this do a good job of extending beyond our sample? And if it does, then we have good external validity. And then lastly, our causal claims. Again, typically here, we're looking at experimental studies or experimental designs. And now, same idea. Not only how well do we define and measure now both of our variables, but also how well have we manipulated any variables that we need to manipulate? Have we done a good job choosing good manipulations to represent the constructs that we're trying to measure? Similar here with statistical validity. Are we estimating things like effect size, margin of error, different types of confidence intervals and things like that? Are these being done and show what we are claiming the results to be? So we just want to keep these statistical values in mind as well, which we're going to get into. We're certainly going to talk more about statistics as the semester goes on, and this will make more sense. But all this idea is that your data, your statistics back up the claim that you're making. Now we have internal validity, and yes, now we're making a causal claim. So we are going to be looking at internal validity here. And again, this is the idea. So if our example is pretending to be Batman helps kids stay on task, well, is this the case? So is them staying on task actually due to them pretending to be Batman, or is it from something else? And so in the study, if we manipulate this, if we control and design this well, hopefully we'll be able to determine that yes, it is from this effect of pretending to be Batman. And if we have some kids pretend to be Batman and some kids pretend to be Superman or not pretend to be anything at all, and we see differences, then we can say that that is directly from the manipulation or the variable that we're measuring. And that would be good internal validity. That's the idea with this one. And then external validity, same idea. Does this apply to all children or just the children in our sample? Does it maybe apply to adults or other groups of people as well? And so external validity, again, how well does that extend beyond the people in your actual study? All right, and then lastly, I'll kind of make the point of, well, how do we prioritize which validity is important? So when we're designing a study or we're kind of interrogating or assessing these different results or claims that are made in research, how do we prioritize which validity is most important? How do we say, well, you had good external validity, but you didn't really have good construct validity? Well, there really is no good answer. There's not one that's always more important than another. It really depends on the design and what you're trying to do. And so sometimes you might really need to focus on one type of validity, and other times you might not have to worry as much about it. For example, if we think about something like external validity, maybe if you are doing some type of study that is looking at the health for everybody, you want to study health and you want to study what makes someone more healthy. Well, that would be really important, I think, to apply to all people in the world or a much larger group. And so you want really high external validity, right? On the other hand, maybe you're doing a different study that is looking at, what makes psychology students able to succeed. And we really just want to focus on psychology students. Well, we're less concerned about maybe as much external validity beyond that scope of participant or population that we're looking at. So again, each particular question, assessment, survey, research depends and can change which validity is more important. And so that wraps up this chapter. I hope you all have a great rest of your week, and please let me know if there's anything I can do for you.